Your brain is designed to keep you alive, but for many neurodivergent people, that same survival system creates daily challenges. What most people call anxiety in autism or ADHD isn't just stress about fitting in. It's the predictable result of a neurotypical world colliding with a fundamentally different kind of mind. And once you understand why this happens, the patterns of neurodivergent anxiety become clearer. The relationship between anxiety and neurodivergent brains is more complex than typically understood. The conventional view treats anxiety as an unfortunate add-on. You have autism, then you develop anxiety on top of it, like catching a cold while you already have the flu. This picture is appealing because it suggests a clean solution. Treat the anxiety with standard methods, and the person will feel better while remaining authentically autistic or ADHD. However, epidemiological data suggests a more complex relationship. Studies by research teams, including those at the University of Rochester and King's College London, consistently find that anxiety disorders occur at much higher rates in neurodivergent populations than in the general population. For adults with ADHD, a 2018 meta-analysis by Solberg and colleagues found anxiety disorders in approximately 50 to 70% of cases. These aren't coincidences. These rates are so high, they suggest something more fundamental is happening. The appealing part of this separate conditions model is that it preserves our intuitions about mental health categories. We like clean boundaries. Autism is about social communication and repetitive behaviors. ADHD is about attention and hyperactivity. Anxiety is about excessive worry. Each gets its own chapter in the diagnostic manual, its own treatment protocols, its own specialists. But the lived experience of neurodivergent individuals often doesn't align with these categorical boundaries. What if the anxiety isn't an add-on at all? What if it's the inevitable result of a brain that processes the world differently being forced to operate in an environment designed for a completely different kind of processing system? To understand why neurodivergent brains generate so much anxiety, you need to think about the brain as a prediction machine, specifically a prediction machine that's been calibrated for a world it doesn't actually live in. Every brain, neurotypical or otherwise, is constantly generating predictions about what's going to happen next. This isn't conscious forecasting. It's happening thousands of times per second, below the level of awareness. Your brain predicts where your foot will land as you walk, what word will come next in a sentence you're hearing, whether that approaching person will make eye contact. When predictions match reality, you feel calm and in control. When they don't, your brain generates what researchers call prediction error, and this mismatch between expectation and reality often manifests as anxiety. This creates particular challenges for neurodivergent brains. Take intolerance of uncertainty, which researchers like Neil Beaudry at the University of Western Ontario have identified as one of the strongest predictors of anxiety in autistic people. In 2019, Beaudry's team found that autistic individuals show significantly higher intolerance of uncertainty than neurotypical controls, and this intolerance directly predicted their anxiety levels. But why would an autistic brain be less tolerant of uncertainty? The answer lies in how these brains process patterns and predictions. Autistic brains appear to rely more heavily on detailed, specific predictions about how situations will unfold. Think of it like the difference between a GPS that recalculates smoothly when you miss a turn versus one that shuts down completely and demands you return to the original route. Neurotypical brains seem to use what we might call fuzzy matching. That they can tolerate significant deviations from their predictions and still maintain a sense that things are going according to plan. If you're neurotypical and your usual coffee shop is closed, your brain quickly adjusts. Coffee shop closed, but there's another one down the street. Pattern still holds, world still makes sense. An autistic brain, by contrast, often relies on precise, detailed predictions. The same closed coffee shop creates a much larger prediction error. Coffee shop should be open at 9 a.m. on Tuesday. Coffee shop is not open. Fundamental assumption about Tuesday morning violated. Recalibration required. This isn't stubbornness or inflexibility. It's a different prediction system encountering data it can't easily integrate. The ADHD brain faces a related but distinct challenge. Research has shown that ADHD brains have altered connectivity between the prefrontal cortex and the amygdala, the brain's fear center. The prefrontal cortex normally acts like a skilled conductor, helping to orchestrate attention and regulate emotional responses, including signals from the amygdala. In ADHD, this regulatory system is less consistent. Imagine trying to focus on a conversation at a party, but your brain's filtering system keeps failing. Every sound, every movement in your peripheral vision, every random thought gets through with equal priority. Your amygdala, designed to detect threats, starts interpreting this constant bombardment of unfiltered information as evidence that something dangerous might be happening. The result is a chronic state of heightened alertness. Your threat detection system is always slightly activated because your attention system can't reliably tell it what to ignore. This creates what I call the neurotypical world problem. Most environments, schools, workplaces, social gatherings, are designed around neurotypical prediction and attention systems. They assume you can handle moderate levels of unpredictability, that you can filter out irrelevant sensory information, that you can quickly adjust your expectations when situations change. For neurodivergent brains, these environments become chronic sources of prediction error. An autistic person walking into an office where the furniture has been rearranged isn't just dealing with change. They're dealing with the collapse of dozens of spatial and procedural predictions they didn't even know they were making. An ADHD person in an open office isn't just distracted. Their threat detection system is being constantly triggered by sensory information their attention system can't filter out. The anxiety isn't irrational. It's the rational response of a brain that's been placed in an environment where its core operating systems, prediction, and attention are constantly under strain. But the picture gets more complicated when you dig deeper into the research. Not all neurodivergent people develop clinical anxiety, and those who do don't all experience it the same way. A 2024 study by Shiza Mahak at Queen's University Belfast found something surprising. While neurodivergent university students showed higher anxiety across multiple measures, they performed just as well as neurotypical students on cognitive reflection tasks, tests of analytical thinking and reasoning. This suggests that neurodivergent anxiety isn't simply about cognitive inability or intellectual overwhelm. The anxiety exists alongside intact reasoning abilities, which points to something more specific about emotional regulation and sensory processing, rather than general cognitive function. The sensory component is particularly crucial and often misunderstood. Recent fMRI research by teams in Japan has shown that autistic brains process sensory timing differently, and this difference becomes more pronounced when anxiety levels are high. It's not just that autistic people are sensitive to sensory input. Their brains are literally extracting different information from the same sensory data, particularly around timing and sequence. Think about walking into a busy restaurant. A neurotypical brain might process this as restaurant sounds, conversation level normal, that music at acceptable volume. An autistic brain might be simultaneously tracking the specific pitch of the espresso machine, the rhythm of footsteps on hardwood floors, the particular frequency of the ventilation system, and the temporal patterns of overlapping conversations. None of this is conscious, but all of it requires neural resources. When the prediction systems are already strained, this additional sensory load can tip the brain into anxiety. The ADHD picture is complicated by what researchers call emotional dysregulation, difficulty managing the intensity of emotional responses. This isn't about being too sensitive or lacking emotional intelligence. Neuroimaging studies by researchers including Castellanos and Proel have documented altered connectivity in networks responsible for emotional regulation, particularly between the anterior cingulate cortex and the amygdala. What this means practically is that emotional responses, including anxiety, tend to be more intense and last longer in ADHD brains. An anxiety response that might last minutes in a neurotypical person can persist for hours in someone with ADHD, not because the triggering situation is more serious, but because the neural circuits responsible for returning to baseline are less efficient. There's also the masking phenomenon, which complicates how we recognize and measure neurodivergent anxiety. Many neurodivergent people, particularly those assigned female at birth, become extraordinarily skilled at suppressing their natural responses and mimicking neurotypical behavior. This masking can be so effective that even trained clinicians miss underlying neurodivergence. But masking comes with a cost. Research by Julia Rischel at the University of California, Davis has shown that chronic masking is associated with increased anxiety, depression, and what's being called autistic burnout, a state of physical and emotional exhaustion that can last months or years. The anxiety in these cases isn't just about navigating a neurotypical world. It's about the additional cognitive load of constantly monitoring and suppressing your natural responses while performing an alternate personality. We also can't ignore the replication crisis that has affected anxiety research more broadly. Many of the brain imaging studies I've mentioned have small sample sizes. and the field is still working out which findings will hold up to larger, more diverse studies. The picture I'm describing is based on the best current evidence, but it's likely to be refined as the research matures. So, what does this mean for how you think about anxiety in neurodivergent brains, whether your own or someone you know? It means recognizing that neurodivergent anxiety often isn't just anxiety in the way we typically understand it. It's not simply excessive worry that can be reasoned away or managed with standard relaxation techniques. It's the nervous system's response to operating in an environment that consistently violates its core processing assumptions. This has practical implications. If you're supporting a neurodivergent person with anxiety, the most effective interventions often focus on environmental modifications rather than just internal coping strategies. For an autistic person, this might mean creating predictable routines, providing advance notice of changes, or reducing sensory load in their environment. For someone with ADHD, it might mean minimizing distractions, breaking tasks into smaller components, or providing external structure for executive functions. This doesn't mean neurodivergent people are fragile or need to be protected from all challenges. It means recognizing that their brains are doing additional work that neurotypical brains don't have to do, and that this work has a cost. When you reduce the environmental load, you free up neural resources that can be directed toward learning, creating, and thriving rather than just surviving. If you're neurodivergent yourself and recognizing your own experience in this description, it can be profoundly validating to understand that your anxiety makes neurobiological sense. You're not broken or weak or failing to cope with things that should be easy. Your brain is responding predictably to a mismatch between its operating system and the environment it's been placed in. This understanding can also guide treatment decisions. Traditional anxiety treatments, cognitive behavioral therapy, exposure therapy, medication can absolutely be helpful for neurodivergent people, but they work best when combined with accommodations that address the underlying environmental mismatch. Therapy that helps you develop coping strategies while ignoring the sensory overload in your workplace is like teaching someone to swim while they're wearing a heavy backpack. Possible, but unnecessarily difficult. The goal isn't to eliminate all anxiety, but some level of activation is normal and even helpful. The goal is to reduce the chronic, unnecessary anxiety that comes from constantly operating in environments that weren't designed for your brain. When that baseline anxiety decreases, you have more resources available for the things that matter to you. This research suggests a different framework. Neurodivergent anxiety isn't a separate condition that happens to co-occur with autism or ADHD. It's the predictable result of prediction and attention systems that work differently being forced to operate in environments designed for neurotypical processing. The anxiety is real, it's significant, and it deserves treatment, but the most effective treatment acknowledges that the problem isn't just inside the person's head, it's in the mismatch between brain and environment. When we design spaces, systems, and expectations that work for different kinds of minds, we don't just reduce anxiety, we unlock the extraordinary capabilities that neurodivergent brains bring to the world. The anxiety was never the real problem. The real problem was assuming that all brains should work the same way.